In this chapter, we learn about electric forces and electric fields. This is the start of our extended tour through a fundamental topic in physics, electromagnetism. It was once thought that electricity and magnetism were independent phenomena. Thanks to James Clerk Maxwell and others, we now know that the two are inextricably related. Even so, we will start with electricity and get to magnetism later. How does the phenomenon of electricity arise in matter? What is its origin? The answer is that the nature of matter is inherent in atomic structure. An atom consists of a small, relatively massive nucleus that contains particles called protons and neutrons. Surrounding the nucleus is a diffuse cloud of orbiting particles called electrons. Like mass, electric charge is an intrinsic property of protons and electrons, and only two types of charge have been discovered, positive and negative. A proton has a positive charge, and an electron has a negative charge. A neutron has zero net electric charge. Experiments reveal that the magnitude of the charge on the proton exactly equals the magnitude of the charge on the electron. The proton carries a charge plus E, and the electron carries a charge minus E. The SI unit for measuring the magnitude of the electric charge is the coulomb, C, and E has been determined experimentally to have the value 1.60 times 10 to the negative 19 coulombs. The symbol E represents only the magnitude of the charge on a proton or an electron and does not include the algebraic sign that indicates whether the charge is positive or negative. Even though the magnitudes of the charge on the electron and the proton are exactly equal, their masses are very different. Protons and neutrons have nearly equal masses of 1.673 times 10 to the negative 27 kilograms and 1.675 times 10 to the negative 27 kilograms, respectively. However, the electron has a mass that is more than 1,800 times smaller than that of the proton at 9.11 times 10 to the negative 31 kilograms. As we will see later, it is the negatively charged electrons that are most mobile and are usually responsible for the motion of charge, including that which you know as electricity that comes from the wall outlets in your house. In nature, atoms are normally found with equal numbers of protons and electrons. Usually, then, an atom carries no net charge because the algebraic sum of the positive charge of the nucleus and the negative charge of the electrons is zero. When an atom or any other object carries no net charge, the object is said to be electrically neutral. The neutrons in the nucleus are electrically neutral particles. Charges of larger magnitude than the charge on an electron or on a proton are built up on an object by adding or removing electrons. Thus, any charge of magnitude q is an integer multiple of E. That is, q equals n times E, where n is an integer and E is the fundamental charge. Because any electric charge q occurs in integer multiples of elementary indivisible charges of magnitude E, electric charge is said to be quantized. One way to visualize this is to consider how mass is quantized in the form of atoms. If we have a kilogram of gold, for instance, we can calculate the number of atoms in a mass of 1 kilogram, since we know the mass of a single atom of gold. We can then say that 1 quantum of gold is a gold atom, and 1 quantum of charge is E, which is equal to 1.6 times 10 to the negative 19 coulombs.